Okay, so let's do the review today. 3-5, March 5th. Who'd ever know? It feels like January, doesn't it? Okay, so write a polynomial. So here's what I've got. Number one, I've got 2i. Guess what? I also have negative 2i. I have both. I have 2i and I have negative 2i. I've got a negative 4, which is a real number. I have a square root of 7, and believe it or not, I also have a negative square root of 7. Now, tomorrow it won't be this big. It will not be this big, but it's okay to practice hard so that when you get the test, it's a lot easier, okay? So how does this work? Couple of ways. First of all, these two, to me, seem obvious. To get a 2, we had to have a square root of 4, right? And to get the I and the negative I, we would had to take a square root of a negative 4. So these two had to have come from an x squared plus 4. Does that make sense? To get these two, right? The 4 had to have come from plain old x plus 4. Would give me a value of negative 4. And then the 7, to get a plus minus square root of 7, I would have had to have taken the square root of 7, right? So it had an x squared minus 7. P of x equals that. Okay? How's that? That's not bad. Yeah, it is pretty easy. Everybody agree? 2. So I'm just going to add, right? So I'm going to add, let's see, I'll get a 14. I can do this on the paper. 14x to the third. These two go together, so it's a 21x squared and a negative 10x, right? On 8, I just have to be careful on the double negatives, right? Just have to be careful on the double negatives. I'll go slowly with it. I can do 8 on the paper also. There's enough room. So, let's do this. I've got an 8x, but I'm going to subtract a negative. You guys see I've subtracted negatives? So I'm really going to add these. Everybody see that? I'm really going to add these. So I'm going to go an 8xy plus, you guys see the plus 15xy gives me a 23xy, okay? I've got a negative 15x, subtract a 3x is going to be a negative 18x. And I've got a 12y, subtract a 5y is going to be a positive 7y. Right? You guys okay with that? Just have to be careful on the subtract the negatives, okay? Alright, 6, and number 4 I'm definitely going to have to do on a separate sheet of paper for sure. Number 4, x to the 6th minus 1, x cubed minus 4x plus 3, and it's just a big old superfoil. This times this, x to the 9th, this times this is a negative 4x to the 7th, this times this is a positive 3x to the 6th. Then, negative 1 times x cubed is a negative 1x cubed. Negative 1 times negative 4x is a positive 4x. And negative 1 times 3 is a negative 3. And you cannot combine anything. They're all completely different. I've got x to the 9th, 7th, 6th, 3's, 2's, and none. So that is my answer. You cannot combine any of those terms. Right? How am I doing? Am I going too fast? Okay, you want me to slow down for a second? I'll wait for you. I'll write down number 5 and I'll wait for you, okay? 3x squared, x plus 2, x plus 5, x minus 3. Okay? Give me thumbs up when you're ready. Saul, you ready? I'll wait for you. Which one?
2. Yeah, ready.
Number 2? I got it. Oh, that's an x cubed. That's an x squared. Oh, that is not an x squared. Thank you, Callan. Thank you. You're right. Okay, you ready?
Yeah.
Here's the way I like to do it. Personally, you can multiply these two first. That's fine. I really like to multiply the second two first. It's just an easier form. You can do these two first if you want to, and then multiply this one. Personally, me, I like to ignore the first one and just multiply these two first. Okay, so I'm just going to ignore that. I'm going to get my x squared minus my 3x plus my 5x minus 15. Okay, I'm just foiling, just multiplying it through. And then I'm going to get a 2x here, right? So I'm going to get a x squared plus a 2x minus 15. And then I'll bring down the 3x plus 2. And again, this is just my preference. I like to have the binomial here when I multiply this through. It's easier for me. You don't have to do it that way, but this works best for me. So then I'm going to get a 3x cubed plus a 6x squared minus 45x. And then I'll multiply through the 2. I'll get a 2x squared. I like to line them up. I really do. This is my preference. 2x squared plus a 4x minus a 30. And when they're lined up, it really makes it easier just to add straight down, right? So I multiplied through. I kept the like terms lined up. And then when I add, just add straight down. 3x cubed plus 8x squared minus 41x minus 30. Okay, how's that? Zip it away. Okay. And flip this over. 6a, I've got an x to the 4th minus a 10x squared plus 9. So this is factor. Factor completely, okay? And then find factor. We're not even going to find the zeros. We're just going to factor. There's no equal sign, okay? So parentheses, 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 right? x squared minus 1 minus 9. Okay? I get my double smiley. I'd get a negative 10x squared. I get a negative 9x squared, and negative 1x squared makes a negative 10x, okay? Thumbs up on that? Oh, thanks, Olivia. And we're not going to solve it because there's no equal sign, right? We're just going to be done. No equal sign, done, right? And then 6b is by grouping. We've got a 4x cubed minus a 2x squared minus 10x plus 5. 4 terms. Let's group them. Let's put these two together and these two together, right? So common multiple of a 2x squared. So a common factor out of 2x squared. I'll have a 2x minus 1. Common multiple of a negative 5. Take out the negative. It really will help. Take out a negative 5, and then you'll have a 2x minus 1. By taking out the negative, you were able to make that a negative 1, which matches up to that one, right? Because you want to make these two the same. You really do. You want to make these two the same. So when I took out the negative, it made that a negative 1. I like that because now these two are the same. So what do they have in common? They have a 2x minus 1. If I take that out, what's left over is a 2x squared minus 5. How am I doing?
Wouldn't one of those two x's be positive?
Great question. Okay, so if I take out the negative, right, then it changes their signs. You with me? So if I take out, Gavin, if I take out the negative, it becomes a positive. If I take out the negative, it becomes a negative, okay? And if you go backwards, think about it this way. This times this makes a negative 10x. Oops, hold on. Right in the middle of that, huh? Hello, Landon. Google account password. Hulu.
Yeah,
I don't know right now. I'm in the middle of teaching. I'll call you back, okay? I love you. I'm recording, okay? All right. Anyway, moving on. 7. All right, we need lots of room to do 7. I'm sorry. 7 is one of the harder problems on the test, but we can do it. I have faith in us. 7, we are not going to miss 7. We're going to get it right, okay? X cubed plus 125 equals 0. So, how many answers?
3.
Okay, let's see if we can get 3 answers. Okay, to get the 3 answers, we're going to factor it. We're going to use this one right here. We're going to use a cubed plus b cubed. Okay, and I'll write that down on my notes. We're going to use our a cubed plus our b cubed equation, right? So let's rewrite this as an x cubed plus a 5 cubed. Okay, you guys see it's a cubed plus a cubed, right? So in this case, my formula is going to be an a plus b times an a squared minus an ab plus a b squared, okay? Well, let's plug x and 5 into my formula. Okay, so in this case, x is going to be a. So I'm going to let x be my a, and we're going to let my 5 be my b. So I'm going to take my x and my 5 and just put it into the equation, all right? So let's see, I'm going to have a x plus 5 times an x squared minus a 5x plus a 5 squared, which is 25, equals 0. Okay, how am I doing? Doing okay? Now, one answer is easy, right? Negative 5. That's the easy one. Okay, right off the bat, x equals negative 5, easy. But this one's going to be a little bit more challenging. We're going to have to use the quadratic formula, okay? So to use the quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a, where a is 1, b is negative 5, and c is 25, okay? So we're going to plug those values into my quadratic formula, and we'll get the other two answers. We might get an I answer, maybe. I don't know. We'll see, okay? So negative b, which is a negative 5, which is a positive 5, right? Negative 5, positive 5, plus or minus square root of b squared, which is a 25. Okay, negative 5 squared is a positive 25, minus 4 times a, which is 1, times c, which is 25, all over 2 times 1, which is 2, okay? Slide it up. So, b squared, 5 squared is 25, minus 4 times a times c, all over 2a. Okay, how am I doing? Keep going? Okay, should I wait for you? I don't mind.
That's the whole answer.
Huh?
That's the whole answer.
No. No, we got some work to do, don't we? We got some work to do. So I got 5 plus or minus the square root of 25 minus 100 all over 2. You have a Gavin, it's not hard work. It's not hard work, right? It's just tedious, right? Okay. Yeah, so I got negative 75. So right off the bat, I know I'm going to have an imaginary answer, right? I am going to have an imaginary answer. Let me do a little side work. Mind if I do a little side work? Okay. Square root of negative 75 is the same thing as 25 times the square root of 3 times the square root of negative 1. A little side work is just going to make it easier if I reduce 75 on the other side, right? So, yeah, I'm going to have 5 square root of 3i. Yep. And let's put that right, let's put this right there, okay? Let's just replace that right there. So let's see what we get. I've got a 5 plus or minus 5 square roots of 3i over 2, and that's really my answer. A better answer, I would take this answer, a better answer, because we're supposed to keep them separate. Really, the rule is keep reals and imaginaries away from each other because they come from different dimensions. Who knows what dimension it might be, right? So it's 5 halves plus or minus 5 half square roots of 3i. Okay, that's a better answer. Because in reality, we're supposed to keep the reals away from the imaginaries. And that's why I rewrote it. Now, if you gave me this, I certainly would take it. But if you don't reduce it, I'm going to take half a point off, okay? How's that look? Yeah. Okay, let me know when you're ready, and we'll flip the page, and we'll do the next one, okay? Okay, and we will turn the page. Let's get it. Oh, I'm sorry. You got it? All right, flip page. Okay, no, 7b. 7b is a 2x cubed plus 5x equals 11x squared. Okay, so what I'm going to do is bring the 11x squared over, okay? Let's bring it over, put it right there. So I have a 2x squared minus 11x cubed, my bad, cubed, minus 11x squared plus 5x equals 0. Now I know we're going to have three answers, right? This is x cubed. Let's common factor out an x first, okay? 2x squared minus 11x plus 5 equals 0, okay? How am I doing? This will factor 2x and x, because that's going to make my 2x squared, right? Now, 5 and 1, but I got to be careful because I need my double smiley, right? I'm going to put my 1 here and my 5 here because that'll make a 10. See my 10? There's my 10. and there's my 1, right? 10 and 1, but I need a negative 11, so negative, negative. I think that's going to make my negative 11, okay? Okay, we're not done, but we're going to be quick, right? So really, we've got 3 answers. X equals 0. That's done. I've got a 2x minus 1 equals 0 and an x minus 5 equals 0, right? Plus 1 divided by 2, how about 1/2? Plus 5, there we go. What do you think? Thumbs up? You can do this tomorrow, can't you? Yeah.
I don't have an like husband.
I'll put that on there later. Yeah, I'll get that on. Yeah. And then Daisy brought up a good thing. If you are taking the test and you need an R value, just ask me. I'll help you get it on there, okay? Okay, you guys ready for number 8, huh? All right, let me get some graph paper out. Graph paper for number 8. Do I have graph paper? I did. I did have graph paper. We'll get some. Here we go. Okay, let's take a look at number 8. Anybody need graph paper? All right, good. You guys are well prepared. All right, number 8. Okay, we're going to graph g of x equals x cubed plus x squared minus 6x, okay? Now, factor and find the zeros. I can do that, okay? X squared plus x minus 6. Okay, it says, and I'm going to look for the work. I mean, I know you can get this off the calculator, but I'm going to look for the factoring, okay? Put a 1 here. So if I'm looking for the zeros, I'm going to set it equal to 0, right? I'm looking for a 0, set it equal to 0. So I'll have x, I'll have an x plus 3, x minus 2, right? And then I'm going to get my zeros at x equals 0, x equals negative 3, and x equals a positive 2. So now I'm probably thinking, okay, if I need to find out the max and mins, I'm going to have to find the max and mins to find increasing and decreasing. Now I'm going to have to use my calculator. But at least at this point, the zeros are pretty easy, right? Okay, so let's go ahead and do this and this. Okay, I know I'm going to have, let's see, how about a 0 at 0, a 0 at negative 3, and a 0 at 2, okay? Now, I kind of got an idea. I kind of know what it looks like, but let's go ahead and graph it on the calculator, get a good picture of it. Let me grab a calculator real quick. And I'm recording. I'll give you guys a chance to catch up. Oh, good. There's a calculator up okay. So let's put it in. Let's go first to y equals, and let's do a x cubed plus an x squared, subtract 6x, and let's graph it. I don't know what my window is. Oh, I got a decent window. Graph it. All right, that's not bad. So we got to find our max and mins, right? We have to. So right off the bat, let's look for our max. So second, calculate looks for our maximum. Okay, left-hand bound. I'll go left-hand side of this, right? Right-hand bound, right-hand side of it. Guess. Okay, here's my max. I'll write that down. My max is at about a negative 1.8. So my max is about a negative 1.8, comma 8.2. All right, let's go for my min. Okay, am I going too fast?
Yeah.
Okay, I'll let you go. So I got my max. 1.8. 1, 2, 3, 4, 5, 6, 7. Okay. Okay, go for my min. So I can calculate my minimum. All right. Left hand bound. Yeah, right about there is good enough. Right hand bound. Just as long as I'm on either side of it, right? Guess. Okay, I got a 1.1. So my minimum is about a 1.1 comma negative 4 about, right? So 1.1 and negative 4 is about there. Okay, so now I can graph it in. Looks just something like this. And up, okay? How am I doing? Now, that's not bad, because we can get everything from our calculator. So if I want to do increasing, decreasing, do me a favor. let's make sure we highlight the x values. It's the x values, okay? It's the x values. When is the graph increasing? What x values? What x values makes it go up or down, okay? So obviously it's going uphill from here to about a negative 1.8, okay? So inwards we can go increasing, decreasing, increasing, right? You could say from negative infinity to negative 1.8. I would take that answer, okay? A better answer might be to say x is less than negative 1.8, okay? But I'll take either one. You okay with that? Negative infinity might be easier for you to interpret, but it's also increasing from x is greater than, yeah, I sure will, yeah. And this is the value at 1.1. So I could also say it's increasing from x is greater than 1.1, or I can say from 1.1 to infinity, okay? I can also say something as crazy as this. You want to see something as crazy? 1.18. Right? What the heck? So let's think about this. Let's see what I put on there. X is less than negative 1.8, yeah. X is greater than 1.1, yeah. So I can wrote it as one single statement, didn't I? I will take any of this. That makes sense? I don't care, as long as you just tell me where it's going uphill. Got it? Now decreasing is pretty easy. Where is it going downhill? Decreasing. It's going downhill from here to here. So it's decreasing from a negative 1.8 less than x less than a 1.1, okay? Decreasing, increasing, okay? A lot of kids miss this, but you guys won't tomorrow, will you? You won't. It's just a matter of where's it going uphill, but I'm going to say it again. It's the x values. What x values make it go uphill? What x values make it go downhill? That's what it's all about. Not the y's, but the x's, okay? Thumbs up? You can do this tomorrow, right? Okay, good. Hey, we're getting there. So, number 9. Okay, you guys ready for number 9? I'm going to grab a calculator. So if it wants a scatter plot, I think. Okay, so let's do a scatter plot real quickly. Good. Alright, get my ruler. Alright, this is number 9. And, alright, I'm going to go 1, 2, 3, 4, 5, 6. And how about I go 100, 200, 300. So I'm really going by 25s. Does that make sense? To make it all fit? Okay, so 1 and 13 is, I don't know, let's see, maybe about here. 2 and 22 is maybe about here. 3 and 49 is maybe right there. 4 and 106 is about there. 5 and 205 is maybe about there. I'm just guesstimating. And 6 and 500, no, 358 is about there, okay? Now, is it quadratic? Is it cubic? Is it quartic? I don't know. Let's check it out. So if you don't have the R value, I'm going to show you how to get the R value on, okay? Real quick. So Daisy, you don't have the R value, right? So let's go to catalog, which is down by the 0, okay? Go to catalog. If you don't have the R value, go to catalog. And we want to go all the way down to find diagnosis. We want to turn on the diagnosis. A, B, C, D. We're going to D, diagnosis. Okay, so we get all the way down to diagnosis. There it is. So I found diagnosis on. So if it's not on and tomorrow it doesn't work, just ask me. I'll help you get it on, okay? Because we need that R squared value, right? So on, and Daisy, I actually have to push enter. You have to push enter to get it on. Push enter, it says done. Your R squared value is going to work now, okay? All right, so let's go back to stat. Let's put this stuff in. Stat, edit, clear my data, clear my data. All right, so I've got a 1, enter 2, 3, 4, 5, 6, right? So put all your data in, list 1, List 2, 13, 22, 49, 106, 205, and 358. Okay, how am I doing? So I got it all in. And then what I need to do is calculate. Now, which one is it? Let's look at, I know for sure it's not linear. You guys agree? I mean, it seems silly to do linear. There's no way that's a straight line, right? So we'll try cubic. Well, actually, we can try quadratic too. We'll try quadratic, cubic. It's probably cubic, but let's go ahead and check it out. Okay, so I'm going to go to Stat, Calculate, and let's try quadratic, and let's check the R value. Okay, quadratic, calculate. So about 0.997. Okay, that's not bad. My R squared. So for quadratic, I get R squared. It's about 0.9971. Okay, yeah, it's pretty good. But let's see if we get a better one. Okay, so let's try calculate cubic. All right, see if we get a better R squared value. You guys know where I'm going with this, right? Enter. Ah, bingo. Bingo, bango, bongo. Which one is it? It's got to be cubic, right? I mean, if I get a 1, it means 100% of the data lines up nicely. So this thing is not quadratic. It's cubic. So what's my equation? It's kind of a nice equation, too. This is definitely cubic. So it is going to be a y equals a 2x cubed minus a 3x squared plus a 4x plus 10. Nice equation, huh?
Mr. Davies,
Yes.
will you please explain again, like, what do you do if none of the things in the graphic calculator fits?
Right, you find the one that has the best, the one that has the lowest degree that has the best R. Okay, does that make sense?
So you just do that?
Yeah.
So, like, it's got a 99% for X to the 2, and then all the other ones didn't.
Right, then I would grab that one, right? Yes, really good question. Okay, so now, predict the profits in year 12. We're just going to let X equal 12. Does that make sense? Just plug 12 in. So I'm going to take and plug 12 in here, plug 12 in, plus plug 12 in, right? And so I'm going to write this as, it would be a y equals a 2 times a 12 cubed, 3 times a 12 squared plus 4 times a 12 plus 10. And then I'm just going to use my calculator. Let my calculator do the work. Okay, you guys ready? I'm just going to go 2 times 12 cubed, subtract 3 times 12 squared plus 48 plus 10. And I get an answer of about 3,082, and that's our profits. That's a good company. It's almost like Amazon or something like that in the early days, huh? Amazon's great. I love Amazon. Amazon has made my life wonderful. I never, ever have to go to the mall ever again. I know some of you girls love the mall. I'm allergic to the malls. Okay, backside, right?
I like malls because they have escalators.
There you go. Okay, number 10. Okay, so we're going to have a, number 10, we're going to have a 3x plus a 2y to the 5th power. What we want is the third term. Okay, so let's start right off with Pascal's triangle. We're going to go a 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, a 1, 5, 10, 10, 5, 1, right? Okay, fifth row. Fifth row because of the 5th power, right? Everybody agree? Okay, now I need the third term. 1, 2, 3. I need the third term. Okay, so let's start with 10. So I'm going to go 10. And now I'm going to go, guys, watch. Shh, John, watch. 3x to the 5th, 3x to the 4th, 3x to the 3rd, right? So I'm going to have a 3x to the 3rd, right? I'm going to go, watch. A 1y to the 5th, a 1y to the 4th, a 1y to the 3rd, a 1y, or a 2y to the 2nd. There it is. That's the actual answer, but let's tidy it up. Let's make it look better, okay? So that is the third term of this polynomial. Okay, so then I'm going to have a 10 times a 27x cubed times a 4y squared, okay? Now think about it. Where did I get the 27? 3 cubed, right? Think about it. Where did I get the 4 from 2 squared, right? So what is 10 times 27 times 4? I don't know. That's what calculators are made for, okay? 10 times 27 times 4. We get 1080 x cubed y squared. How's that? Daisy.
Would you accept it if I separated like so I that would be 270 x to the third times 40 x y to y squared. Would you accept that?
Nah, go all the way. Multiply everything out. Yeah, Ashley?
I'm confused. Why is it 2y to the second? If it's 10, isn't it to the third?
Hold on. Hello? Yes, hi, Ann. Hello. I think that's it, yes. You did. I did it yesterday morning or the Perfect. Thank you so much. All right. So Ashley, ask your question. Sorry.
So, if we write out the equation, shouldn't it be 2y at the very beginning? Shouldn't it be 2y to the third? Because if you're moving back, it's the third term, so it's 5, 4, 3, not 5, 4, 2.
If I want the third term, that's the third term, right? Right? That's the third term. First term, second term, third term, right? You with me? And then if I do my 2i5, 2i4, 2i3, 2i2, plus nothing, you guys, these exponents have to make 5. Ashley, does that help? These exponents absolutely have to make 5.
Okay, it's okay. I'll figure it out.
Okay, let me keep going. All right, almost done, and then I got to figure out what the doctor's all going to do. Okay, 11. Find the equations. So first of all, here's what I know. I'm going to have y equals, you ready? I'm going to have a x plus 2 twice, because I have a 0 of negative 2 twice. You okay with that? Occurs twice here, that's a double root. And I'm going to have an x minus 3. And I'm going to have a 1, 2, 3, 4, 5, 6. And an x minus 6. Okay, everybody okay with that? Now, it's got to go through the point 0, 3. It has to go through this point right there, okay? Now, that means there's some number in front, we'll call it a, that will make it go through this point. Now, we know a is positive. It has to be positive because it ends going this way. So, we're going to go y equals some a value, x plus 2, x plus 2, x minus 3, x minus 6. Okay, now, how do we find the value of a? We've got to just plug in our point. So if we want to force this equation to go through 0, 3, put 0, 3 into the equation, and we'll find the a value that'll do it. Okay, so 3 is a y value. Let's put the 3 there. Okay, 0.
That in the calculator.
Yeah. 0 is my x value, so we'll go 0 plus 2 times another 0 plus 2 times a 0 minus 3 times a 0 minus 6. How am I doing? Okay. So I plugged the 3 in for my y value, the 0 in for all my x's. So let's simplify this. We've got 3 is equal to a times 2 times negative 3 times negative 6, right? 4 times 18. What's 4 times 18? I don't know. 72. So we got 3 equals a times 72, right? Divide by 72. 3 over 72. I think that will reduce. Let's see, both by 3. What's 72 divided by 3? Take a second. 24. So I get 1/24 is what A is equal to. Okay, so I reduce it. So my grand answer, ready? I have A. Let's take that answer. Let's take A and let's plug it right there, huh? So the answer of my polynomial is going to be, I like P of X, x plus 2 times x plus 2, or x plus 2 squared, times my x minus 3 times my x minus 6, but it's multiplied by a 1/24. So that's my value of A. How's that? All right, 12, almost done, right? So, I got x cubed. Now, an x cubed equation looks like this. I don't know if you remember that, but that's what x cubed looks like. That's the parent function, okay? So, what are we going to do? We're going to translate it one unit to the right. So, we're going to take an x minus 1 cubed, because we'll go the opposite of the inside, right? Opposite. And then 5 units down. And they're going to shrink the whole thing by 1/2. That's my equation. So to graph that, another piece of graph paper. Hold on, another piece of graph paper, and then I'll be done. A lot of interruptions today, huh? Yeah.
Wouldn't it be -5? It's not opposite.
Did I make a mistake? Yeah. Ah, yeah. Thank you, Rory. Thank you very much. So let's see what it looks like, okay? And then I'm done. I got a little work for you to do. Last homework of this chapter, huh? Okay. So I know it's going to be at